For question 7, you're given a point and a gradient. So as with the previous question, we need to use the tool y minus y1 equals n, x minus x1. Substitute in and simplify. And we get our result, y equals minus a half x plus 6. Okay, part B, these are always a bit odd, these questions. You're given a point and asked to show that it lies on a line. In other words, the point has to satisfy the equation. The most rigorous way of doing this is to substitute the x-coordinate and see if you get the correct y-coordinate out. So we've got our equation as the answer to part A. We're going to substitute the point minus 2 in for x, so the value minus 2 in for x, and just simplify that down, and oh, lo and behold, we get 7. So that's good. The reason they've included that part B is so that if you can't get that correct result, if you don't get 7 there, it means you made a mistake in part A, and they don't want you to press on into parts C and D unless you've got the correct answer for part A. So that's why they do that for just 1 mark. It's a pretty easy mark to get, really, and it helps you to get all the marks from part A because it stops you from, it should help you realise you made a mistake if you have made one. Okay, part C. I go back to the end of part B. We need to conclude. So whenever you do a show that or a prove, don't just get an answer, but write down what that means. So usually it means just paraphrasing the question. So point B lies on L1. Now let's look at part C. Find the length AB. Well, we know A is 2,5. B is minus 2,7. We've just got to find the distance. We're using the Pythagorean distance formula. The difference between the x-coordinates of those 2 points, A and B, squared, plus the difference between the y-coordinates of those 2 points, squared, gives us 4 squared plus 2 squared, all square rooted, which is root 20, which is, of course, 2 root 5. Again, if you don't get something that's some number of root 5s, you know you've made a mistake because it's telling you in the question what form to expect your answer in, k root 5. Now, I think now we've come to the only actually tricky part of this question, which is it calls it part C, but of course it's part D. So part D, you're given a point C and you're told the x-coordinate is just called P. So can we write down a coordinate pair for point C? Well, we know that the x-coordinate is P, so let's put P comma. Now, notice that we have a formula here for y in terms of x. So if x is P, y must be minus a half P plus 6. There's our coordinates for C. Brilliant, we've got it. Now, just because I know what we're going to be doing with this, I'm going to write it the other way round. So instead of minus a half P plus 6, let's write this as 6 minus a half P. And I'm also just for convenience going to write down the coordinates of point A again there too. And again, we're using the Pythagorean distance formula. So the difference between the x-coordinates of those is P minus 2, square it, plus the difference between the y-coordinates of those 2 points, squared. And we're told that in the question that that's equal to 5. Now, getting rid of the square roots on both sides of the equation, so square both sides of the equation. I'm also going to simplify that bracket there. 6 take away 5, of course, gives us that 1. And square the right-hand side as well, and we get 25. Now we need to expand everything. Take time over this expansion. I'm potentially missing out a step here. And running out of space. Let's gather together the like terms on that left-hand side. We've got 1 1/4 p squared, or 5 quarters p squared. We've got minus 5p. We've got 5, and that all equals 25. I can see there's a factor of 5 in every term, so I'm just going to swipe those out now, divide everything by 5. And then I'm going to get rid of the fraction by multiplying everything by 4. And then do what I could have done earlier and subtract that term on the right from both sides of the equation to give the result requested.